A young athlete in seemingly perfect shape suddenly collapses one day and dies. How could this possibly happen? This problem is that the athlete was either never screened or that the screening falsely said the athlete was healthy. Such an undesirable scenario presents itself in the case of diagnosing left ventricular hypertrophy, or LVH, which appears virtually identical to the heart of a healthy athlete on the standard 12-lead electrocardiogram, posing a major problem. The key difference between LVH and athlete's heart is the asymmetrical growth of the septum in LVH. This asymmetry is significant because it can unevenly prolong the propagation of an electrical wavefront, possibly destabilizing the rhythm of the heart and leading to death. Yet, the 12-lead EKG only reads information from the frontal and horizontal planes of the body, and due to the orientation of the heart slightly turned toward the posterior, the asymmetry of the septum manifests in the sagittal plane, and thus doesn't show up on the 12-lead EKG. To resolve this ambiguity, I decided to look at the heart in 3 dimensions. I applied a regression to the 12 leads to get orthogonal images of the heart, and used this to obtain the components of the peak depolarization and repolarization vectors. The asymmetry deflects the vectors relative to each other, so I calculated the angle between them for a group of subjects with LVH and a group of athletes, and compared the results to traditional parameters used in clinics today. For the LVH group, the traditional parameters reported 83% of the patients correctly as positive. The angle, on the other hand, reported 100% of the patients as positive, which means it has a higher sensitivity and thus saves more lives. For the athletes, the traditional parameters reported 0 and 25% of the healthy athletes correctly as healthy. On the other hand, the angle had a 100% accuracy, meaning it dramatically cuts down false positive rates and is much more specific. Clinical implementation of the angle would be inexpensive and could have an immediate impact, as the method requires no new hardware and is computationally very simple. Currently, universal athlete screenings are impractical due to a high rate of false positives, but the angle resolves this ambiguity and makes substantial progress towards accurate, cost-effective, and widely available